morning, friends. I am Professor G.B. Deshpande, Mechanical Engineering Department, SBM Polytechnic, Mumbai. Today's topic is Introduction to Jig and Fixture Design. Learning outcomes. After watching this video, you will be able to identify jig and fixture, apply 3 to 1 principle required for jig and fixture design, identify locating and supporting elements. Introduction to jig and fixture. Jig and fixtures are special purpose tools used for mass production having following advantages: facilitate production at mass scale, reduce cost of production, assure high accuracy of the parts, provide interchangeability, less skilled labor, saving in labor, safety at work. So, by using jig and fixtures, we can get these advantages. So, next, introduction to jig fixture. When a workpiece is kept and machining is required on the surface with the help of cutter, we require to give support at the bottom. Then to stop the further movement of the workpiece, we require a locator, which is a fixed jaw, and to hold the workpiece we require a movable jaw, which is called as a clamp. When we mount all these on a body, it's called as a fixture. So vice is a fixture. Fixture is a device which holds position the work but does not in itself guide, locate or position the cutting tool. Examples: turning fixture, milling fixture, grinding fixture, etc. So we can conclude that a fixture is a device which positions the workpiece but does not guide the cutting tool. Workpiece is kept in a space and a support is body is kept and a workpiece is there. From front side, if we give a stopper which is called as a locator, and at the bottom we give support, and to hold the workpiece we provide a clamp, and to guide the cutting tool if we add a cutting tool guide element, which is bush, and carrying out a drilling operation. In that case, the cutting tool is guided by a bush. So we can define jig is a device which holds, positions the workpiece and locates or guide the cutting tool relative to the workpiece. So example of jig are drilling jig, reaming jig, tapping jig, etc. So we can conclude that a device which holds, positions the workpiece and guide the cutting tool is called as a jig. So we can differentiate between jig and fixture such that A fixture is a device which only locates or holds the position of workpiece, which does not have a cutting tool guiding element, whereas in a jig, which holds positions the workpiece and having an additional element which is a cutting tool guide element. So, to design a jig and a fixture, the basic principle required is 3 to 1 principle. Now, assume that a free body is kept in space along the three axes, that is x, y, z. Now, a question is there: in how many directions a free body kept in space can move, rotate about axis x, y, z. Second one, how to restrict these motions to bring free body to the required position. Stop the video, write down your answers in your notebook. Once you complete, start video again. Now, 3 to 1 principle. Body is kept along these three axes x, y, z. Now, in how many directions it can move or rotate? Just check. X forward, X backward, X clockwise, X anti-clockwise. Similarly, Y forward, Y backward, Y clockwise, Y anti-clockwise. Z upward, Z downward, Z clockwise, Z anti-clockwise. So total degree of freedom is 12. So in 12 directions it may rotate or move. So if we want to bring the object to the required position, we have to make some arrangements for that. To restrict the motions of workpiece, if we add 3 pins at the bottom of the workpiece, that is pin A, pin B and pin C, you can restrict total 5 motions, or you can say 5 movements of the workpiece, that is clockwise x, anti-clockwise x, clockwise y, anti-clockwise y, and z downward. So by adding 3 pins we can restrict 5 motions. Now by adding 2 more pins perpendicular on a plane of a previous 3 pins, that is pin D, pin E. In that case we can further stop 2 motions, that is clockwise, Z clockwise and Z anti-clockwise. That is 6, 7, and X backward, that is 8. Now if we add one more pin F from perpendicular plane to the workpiece, again it will restrict direction 9. So by adding 6 pins, that is A, B, C, D, E, F, restricts 9 degrees of freedom. So still 3 degrees of freedom is left, that is 10, 11, and 12. So Z upward, X forward, and Y forward. So to restrict these remaining 3 degrees of freedom, we have to use clamp. Now if a workpiece is kept in a fixed body, which is called as fixture body or a jig body, and if we add 3 pins at the bottom of the workpiece, that is you can see 3 pins added at the bottom of the workpiece, their respective positions in other two views. You can see 3 pins at the bottom, now if we add 2 more pins from the side, after adding 3 pins A, B, C, we can restrict motion 1, 2, 3, 4, 5, that is X clockwise, X anti-clockwise, Y clockwise, Y anti-clockwise, and Z downward. Now by adding 2 more pins, we can restrict further 3 motions, that is D, E. After adding, you can restrict 6, 7, and 8, which is nothing but Z clockwise, Z anti-clockwise, and Y. Now by adding one more pin, that is F, we can restrict further one more direction, that is Y backward. So total 9 degrees of freedom we can restrict, as we are using 3 to 1 pins. This is called as 3 to 1 principle. Now here the 3 pins which we have used at the bottom, A, B, C, are called as support or locators. Those are sometimes fixed or adjustable depending upon the condition, whereas pins D, E, and F are called as locators, and these pins are fixed. So we can conclude that supporters are the elements which gives support to the workpiece, and those may be fixed or adjustable with respect to their positions, whereas the locators are the fixed elements from where we maintain the required dimensions for machining. So jig and fixture, we require these two elements, and to control the remaining 3 degrees of freedom we require a clamping element. Thank you for watching this video. If you have any doubt, contact me on given details. Thank you.